class. We're about to start the second part of Lesson 7, Chapter 4. It says dependent and independent probability. You know how to find the probability of a single event. You can use this knowledge to find the probability of two or more events. Example 3. Brad tosses 2 quarters into the air. What is the probability that both will land so that the head sides are shown? One way to solve the problem is to list or diagram all the possible outcomes. So quarter number 1 is heads. We got quarter number 2 could be heads. Quarter number 2 could be tails. So we have the possibility of 2 heads or a head and a tail. If quarter number 1 is tails, quarter number 2 could be head, and quarter number 2 could be tails. So we could have tail, head, tail, tail. There are 4 possible outcomes, and only one is favorable, head, head. Therefore, the probability of having both land with the head side up is 1/4 or 25%. You can also use multiplication to find the probability. Find the probability of the individual events. The probability that one coin would be heads is 1/2, and the probability that the other would be heads is 1/2. Multiply to find the probability of both events. So 1/2 times 1/2 is 1/4. The 2 coin tosses in example 3 are independent events. When events are independent, one does not affect the probability of another. In example 4 below, the events are dependent. Once the first event takes place, the probability of the second event is changed. So now again, this is important. The difference between independent events and dependent events is with the independent events, one does not affect the probability of another. But when dependent events happen, the probability of the second event is changed. So let's scroll down here to example 4. It says a box contains 4 blue marbles and 2 red marbles. If you select 2 marbles, what is the probability that the both will be blue? Hint, even though the marbles in the box are taken out at the same time, think of one as the first marble and the other as the second marble. There are 6 marbles in the box, and 4 are blue. The probability that the first marble will be blue is 4 out of 6, which reduces to 2/3. Assume the first marble selected is blue. Now there are only 5 marbles in the box, and 3 are blue. The probability that the second marble will be blue is 3 out of 5. Because remember, when you pull out that first marble, they're assuming that you're not putting that marble back in. So if you assume that that first marble is blue that you pulled out, that means that instead of it being 6 overall marbles, it's only going to be 5. And instead of being 4 blue, it's only going to be 3 blue. So this is how it's dependent, where it can change the value of the second probability. Say multiply to find the probability of the 2 events. So we have to take 2/3 times 3/5, which is 6 over 15, which is 2/5. So the probability that both marbles will be blue is 2 out of 5. The events in example 4 would not be dependent if the first marble were replaced before the second marble was selected. Always think carefully about the situation to decide whether 2 events are dependent or independent. Now listen, when they talk about replacement, that means when you pull a marble out, like we did here, we pulled a marble out and say it was blue. We said for the second marble that you pulled out, you did not put that blue you pulled out in the first place. But here, if you were to put the blue back, like say you pulled the blue out, you put the blue back, then it will become an independent event because it would not affect anything, because you would have the same amount of marbles when you were selecting the second time. So let's scroll down here. Now we have, it says here, solve as directed. Express answers as fractions. Kim rolls 2 standard 6-sided dice. What is the chance that both would be 4? Okay, so both of them are 6-sided dice. So what we would do with this, so this is problem number 1. So on the first die, I should say, it'll be 1/6 because you'll get a 4 out of the 6 values. Multiplied by the second die, with it also being 4, is still 1/6. They are both independent of each other because the first die does not affect the second die as far as the probability. So you'll multiply this will be 1/36. So that would be your number 1. Now number 2, 10 cards are numbered from 1 to 10. Tony draws out a card, replaces it, and then draws another card. What is the probability that both cards will be numbers greater than 5? So first of all, we had a probability. So they tell us we have 10 cards. So we'll put this over 10. And they're numbered 1 to 10. Now it says, what is the probability that both cards will be numbered greater than 5? So we know in numbering cards 1, 2, 3, 4, 5, those wouldn't count. So it'll be 6, 7, 8, 9, and 10. So it's 5 cards that's greater than 5. So that would give us 5 out of 10 for the first selection. Now we'll multiply by the second selection. Now they said here that Tony draws out a card, replaces it. So that means Tony put that card right back in there. So you still have 10 possible choices. And then they still want numbers greater than 5. So it still will be 5/10. So now when we multiply this, we would do top times top, bottom times bottom. So this will give us 25/100. Now it does not tell us that we cannot use a calculator, but actually we could do this by hand. We could divide both of these by 25. So we would have 25 divided by 25 is 1. 100 divided by 25 is 4. So it's 1/4. So now we move on to problem number 3. It says a spinner has 4 equal sections. 2 sections are red, 1 is green, and 1 is blue. If the spinner is spun 3 times, what is the probability that all 3 spins will be red? Now we know that spinning a spinner is not going to affect the spinner each time you spin. The spaces would still be there. It's not like taking a card out of, or taking a marble out of a bag and not putting it back. When you spin, those spaces are still there. So now we have 3 values here. So now they tell us, so going here with number 3, they tell us here that it's 4 equal sections. 2 sections are red, 1 is green, and 1 is blue. If the spinner is spun 3 times, what is the probability that all 3 spins will be red? So all of them will have the same probability. Remember, red is 2 out of the 4. It's 2 out of 4. So we multiply each one of them by 2/4. So each time you spin, you got a 2/4 chance of getting on red. So this would be 8 out of 64 when you multiply this out. Now 8 and 64 both has 8 in common. So this would end up being 1/8. So your answer here would be 1 out of 8. All right, now we go here to number 4. It says 20 marbles are placed in a bag. 10 are red and 10 are black. Okay, that's nice. It's only 2 types of marbles. 1 marble is drawn from the bag and set aside. So this is not replaced. So this is a dependent situation. Another marble is drawn from the bag. What is the chance that both marbles will be red? Okay, so now we got to do a little something different here. It's not that much different, but it's still a little different. So this is number 4. So the first marble we pulled would be out of 20. And they said, what is the chance that both marbles are red? So we know it's 10 out of 20 because it's 10 marbles that are red. Now we multiply. Now remember, we're assuming that we got that red marble that first time. Okay, now we set that marble to the side. So if we set that marble to the side, that means there's only 19 marbles left because that red marble has been set to the side. And since that red marble has been set to the side, that means it's no longer 10 red marbles, it's only 9. So now we multiply. 10 times 9 is 90. 20 times 19 is 380. Now both of these have 10 in common. So we'd divide both of these by 10, and this would give us 9 over 18. No, I'm sorry, I wrote that wrong. This is supposed to be 380, not 180. So it'd be 9 over 38. So this would be our final answer, 9 over 38. Okay, so now that took care of problem number 4. Now, problem number 5. It says Allison tosses a coin 4 times. What is the chance that the coin would be heads all 4 times? So this is independent because flipping the coins will not affect the probability. Now we know heads, you can only get, it's 1 out of 2, it's heads or tails. So she tosses it 4 times, so it'll be 1/2 the first, 1/2 the second, 1/2 the third, and 1/2 the fourth. So we'll multiply straight across. 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it'll be 1 over 16. Now number 6. If you roll 2 standard dice, what is the probability that both will be an odd number? Now this is another independent situation because remember, one die does not affect the other die. So now we have our probability. It says, what is the probability that both will be odd? Now on a standard die, you have 3, you got 1, 2, 3, 4, 5, 6. 3 of the numbers are odd, 3 are even. So both to be odd, it'll be 3 over 6 on the first and 3 over 6 on the second. So 3 times 3 is 9, 6 times 6 is 36. We can divide both by 9, and that would give us 1/4. So our answer here would be 1/4. All right, so now we took care of problem 6. Now we move down here. Now it says choose the one best answer to each question. You may use your calculator. Questions 7 and 8 refer to the following information. In a game, a player rolls a die number from 1 to 6 and spins a spinner. The spinner is shown below. What is the probability of rolling a 5, then spinning an even number? Okay. So now we are going to pull up this calculator. Now this is problem number 7. Now we want the probability of rolling a 5. Now remember, this is a standard die from 1 to 6. So you have a 1 out of 6 chance of rolling a 5 on the die. So you have a 1 out of 6 chance. Okay, now, and then it says, and then spinning an even number. Now, if you look at the spinner, it's 6 spaces here. And they said an even number. There are 3 even numbers here. So that'll be 3 out of 6, or 3 over 6. So now we'll multiply. 1 times 3 is 3. 6 times 6 is 36. We'll divide both by 3, and the probability is 1/12. That's 1/12 of you rolling a 5 and then spinning an even number. Now, actually, I should have did this as we could use a calculator. If we hit N over D, we could put the 3 down arrow 36 and then press enter, and it gave us 1/12, which is A. So that would be what we would select. Okay, now that took care of problem number 7. Now we go here to problem 8. It says, what is the chance that a player would get a 3 on both the die and a spinner? A 3. Okay. I'm pretty sure we can handle that. So number 8. So we have a probability of a 3 on a die. So that would be 1 over 6. And then a 3 on the spinner. That still would be 1 over 6. So we will multiply 1 over 6 times 1 over 6 is 1 over 36, which is D. Okay, now for number 9, it says Daniel used the 10 cards below in a magic trick. Daniel shuffles the cards and asks an audience member to choose and hold 2 cards. If the cards are chosen randomly, what is the chance that both will be marked with a square? So, again, whenever I've seen magic tricks, and I've heard people tell a person to pick a card, pick any card, they do not replace the card. So that means that this is a dependent situation. So, what we would do with problem number 9, we would take, okay, so it's 10 cards. So we had a probability, and it says here, what is the chance that both will be marked with a square? So we had, what's that, 3, 4, 5. We got 6 that are squares, 6 out of 10. So it's 6 out of 10 for the first draw. You got a probability of 6 out of 10 to draw the first one. But remember, it's assumed that the first one is a square. So that means your possible choices goes down to 9. And then since we're looking for another square, it'll only be 5 square cards left. So now we multiply. 6 times 5 is 30. 10 times 9 is 90. Now we take our calculator. Press N over D. We'll test 30. We'll hit the down arrow. 90. And press enter. So it's 1/3. Now we know when we're dealing with a fraction, the numerator comes before out. So this is 1 out of 3. So it's 1 out of 3, which is C. So that is your final answer for number 9. Okay, now for number 10, it says there are 15 colored chips in a bag. 8 are green and 7 are white. 5 white chips are removed. What is the probability that the next chip selected will be green? Okay, now, first of all, we want to know the probability that the next chip will be green. Okay, so they tell us that 5 white chips are removed. Now remember, there's 15 colored chips. So if 5 white chips are removed, then that means that it's only 10 colored chips left. So there we go. So now we got our denominator. We got 10 chips left. Now since we removed 5, that means there is only 2 whites and then 8 green. Now, they said, what is the probability that the next chip selected is green? So it'll be 8 out of 10. Now, if you notice here, we have this as a percent. So we'll hit N over D, 8, down arrow 10, press our right arrow, press second, right parenthesis, and press enter. So that's 80%. 80%, which is B. And that finishes off this last part of lesson 7. So I will upload this on YouTube, and you all have a wonderful day.